In this lecture, we're going to look at explicit data conversions. And these are conversions that are actively initiated by the developer. The problem is really what we have been dealing with in the last lecture. It is that in real-world applications, expressions are going to have different types in an expression. And for the compiler to be able to do its thing, it expects all the variables in an expression to be of the same type. One solution is to let the compiler insert implicit conversions for you. And if what the compiler does is what you want, that's going to be fine. But sometimes you really need to get in and tell the compiler what to do. And that's when you do explicit data conversions. Okay, you might have an expression like this which has doubles and integers, and you really want to tell the compiler how it is going to do implicit conversions here. The way you do that, you're going to do what we call implicit cast. And the cast is really a transformation from one type to another. Okay, if you look at the example here, on the left we have an integer which is going to collect the result of this addition operation. But on the right of the assignment, we have double types. So what is going to happen here? We are doing an assignment. What we have on the left, we evaluate to a double because we have double operands. And we are doing an assignment. So the conversion is going to go from double to int. But we might want to do an explicit cast. And we can do something like this using an operator we have in C++. It is called static cast, and it is used to convert from one type to another. What you want to convert from is going to be within this parenthesis, and what you want to convert to is going to be within the angle brackets here. So what we have down here, we have two doubles, and our sum, which is going to be an int, is going to collect the result. We can explicitly cast each operand to int and then add them up. So what we are doing here is taking x and transforming that into an int. We are taking y, transforming that into an int, and then we are going to add up those two integers, and we are going to get the result by adding these integers up and collect the result into this sum variable here. And then we are going to print this up. This is one option, but we can also do the sum before we do the cast. And we can do something like this. We're going to add up x and y, which is going to give us a double. And we're going to take that double and turn that into an integer. And that integer is going to be assigned to our sum variable. And then we're going to print this up. This is also another option, and what you choose to do is going to depend on your preferences or whatever design you are using in your application. But these are options you can choose from if you want to do explicit conversions using static cast in C++. There is another way you can do this. You can use old style C casts, and this is an older method which is really not safe. And the way you do this, you take whatever it is on the right of the assignment, and this is going to be our transformation. And what we want to transform from is this pi here. It's going to go to the right. And what we want to transform to, which is this int, is going to be on the left. And hopefully you can see that this is not as intuitive as what we had with static casts, but it is an older way of doing this. And I think it is kept in the C++ programming language for backward compatibility reasons. So we want the C++ code that we write today to be compatible with C++ code that's been written 10 years ago or 15 years ago, because this is a pretty old way of doing this. But if you are writing C++ code today, we recommend to use C++ casts over C-style casts. The reason is that static cast is really going to state our intent, and somebody is going to look at that, is going to exactly see that we are transforming from one type to another. Another thing is that they are easy to search for in code. For example, if you want to find locations in your code where you are doing explicit conversions, you can search for this static cast keyword in your program, and you're going to easily find that. Another reason is that these casts are checked by the compiler. And sometimes you may be doing conversions between things that are really not compatible. And when you are doing that, the compiler is going to catch that and give you a compiler error. So C++ casts like static cast are what you should really use in favor of C-style casts. Static cast is actually one of the available ways to do transformations between data types in modern C++. And we are going to be learning about others as we progress in the course. So this is really all about the theory. I think it is time we went to Visual Studio Code and actually try these things out. Here we are in our working folder, and the current project is Explicit Data Conversions. That's what we're going to do. We're going to copy our template files and put them where they should be for this lecture. We're going to go up and open this up in Visual Studio Code pretty quick. We're going to open Explicit Data Conversions. We're going to open main CPP up, and we're going to remove whatever it is we don't need in this project. Let's put in some code so that we can play with it. Exactly what we saw in the slides. This is what we're going to do. We have two double variables, x and y. We are summing them up here. And the compiler is going to do implicit conversion from what we have to the right of the assignment to what we have on the left. And we are going to be going from double to int. If we print this up, we're going to see the sum. And let's try this out. We're going to open the terminal here, and we're going to try and build. We're going to run the task to build with GCC. The build is going to go through, so if we try to run Rooster, we're going to see the sum is 47. So if you add these two numbers up, what you're going to get is 47.1, and the 1 is going to be chopped off because we are doing a narrowing conversion, and if we print this up, we're going to get 47. This is what we expect. But we can also do an explicit conversion from double to int if that's what we want, and it makes sense for whatever application we are designing. In this case, we are going to cast and then sum up. And the way we're going to do this, we're going to take x, turn that into an integer. We're going to take y, turn that into an integer. And we're going to add these integers up. And we're going to get the sum in here. If we print this out, and let's copy that and put that here so that we don't type this. And we build again. We're going to build with GCC. The build is going to go through. If we run this, we're going to print 46. Why is that? Well, x is going to be turned into an integer. We're going to get 12. Y is going to be turned into an integer. We're going to get 34. And if we add these up, we're going to get 46. You can see that the answers you get depend on the order in which the conversions are really happening. And sometimes these conversions are going to make sense for whatever application you are doing. And that's why sometimes you will need to jump in and override whatever implicit conversions that the compiler is doing. Another thing we can do is sum up and then cast. And we're going to do that like this. We're going to add up x and y, and then the result of that is going to be cast back to an int. And when we do this, we're going to get the same result we had with implicit conversions done by the compiler. Because we are basically doing the same thing as the compiler, we are adding this up as doubles, and we're going to turn the result into an int and then assign that to this integer here. So we're going to get the same thing. But before we run, try to run this up in your mind and see if you really understand what is going to happen. And when you are ready, hit run task. We're going to choose GCC. The build is going to go through, and if we run this, we're going to get a 47 like we had with implicit conversions here. The last thing we're going to see is that we can also do explicit conversions using the older C style. Let's just put in some test code here pretty fast. And we have a pi variable whose type is double, and we want to turn this into an integer. One way we can do this is to do a cast like this. And on the right of the assignment, this is where the transformation is going to happen. So in the parentheses to the right here, we have what we want to transform from. And in the left pair of parentheses here, we have the type we want to transform to. And when we print this up, we're going to get pi, which is a double, but we can also print our int pi. So let's do that, int pi. And if we print this out, we're going to do it like this, and stdndl. And if we build this, let's see if the build goes through. The build is going to be good. and we can run rooster, and we're going to see pi is 3.14, but int pi is 3. The conversion was successful, and we are seemingly getting the same results we had with static cast. This is basically the same as doing int pi, and we're going to say equals static cast, and we're going to cast to int, and what we're going to cast is pi. So this is going to give us the same result. Let's try and build this. The build is going to go through. If we run this, we're going to get the same result, but a static cast is safer than a Nolder style C cast because of the reasons we have discussed in our slides. Again, static cast make it really clear what your intent is. If somebody looks at that, he's going to know that you are doing transformation from one type to another. But another big benefit is that the transformations or the casts are checked by the compiler. And if you are trying to transform between two incompatible types, you're going to get a compiler error. We can't really give you an example of this because we don't have enough tools to do that, but we're going to definitely see this as we progress in the course. This is really all I had to share about explicit data conversions. I hope you really understand this. We're going to stop here in this lecture. In the next lecture, we're going to see how data can overflow or underflow. Go ahead and finish up here and meet me there.